Students, let us solve this Irodov problem 1.26, a very good problem. A point move in the xy according to the law x equal to a sine omega t, y equal to a into 1 minus cos omega t, where a and omega are positive constants. What is given? In this question, a point move such that its x coordinate changes with time and y coordinate changes with time. The x coordinate equation is x equal to a sine omega t, and the equation of y coordinate is y equal to a minus a into cos omega t. We have to find in first part the distance s traversed by the point during the time tau. Keep in mind that the question does not ask the displacement, it asks the distance. So how to calculate the distance in time tau? To calculate the distance, the formula is integration of speed into dt. Remember that this is not velocity, this is speed. Integration of a speed with respect to time gives the total travel path length. So from where to where? From 0 to time tau. Okay. To, to calculate this distance, I need the speed equation. So how to get the speed equation? If I differentiate this position with respect to time, I get the equation of velocity. So what is the equation of velocity? So this is a constant. Differentiation of sine theta is cos theta, but here omega is multiplied with time t, so omega will come out. So Vx should be equal to omega into a cos omega t. Okay. What is the velocity in y direction? Differentiate this y with respect to time. So this is a constant. Differentiation of this part is 0. Differentiation of cos theta is minus sine theta. So 1 minus and there is a minus. So it should be plus. Now when we differentiate cos theta, it will come out sine theta. But this is not theta, this is omega into t. So omega will come out and Vy equal to omega into a sine omega t. So this is the velocity part. Now if I differentiate it further, I get the acceleration. So acceleration in x direction should be equal to differentiation of cos theta is minus sine theta. So there will be a minus and 1 omega further come out. So this will be equal to omega square a sine omega t. Yes, this is the acceleration in x direction. Similarly, differentiate this part. Acceleration in y direction is differentiation of sine theta is plus cos theta. So this would be plus and 1 omega will be come out. So omega square a and cos omega t. Yes, this is the differentiation. Okay. So what is the velocity? In vector form, velocity is omega a cos omega t, this velocity in I cap plus this velocity part in j cap. So omega a sine omega t in y direction. Now I have to find the speed. Speed means the magnitude of velocity. So magnitude of velocity means it should be equal to under root magnitude of this part. So omega a is common. So omega a cos omega t square plus omega a sine omega t square. Omega square a square will be common and this will result cos square omega t plus sine square omega t, which is 1. Sine square theta plus cos square theta will be always 1. So V comes out omega into a. So this speed is constant. the position of x and the position of y is a time dependent function, but the speed of particle does not depends on time. Speed is constant, velocity is time dependent. This velocity is time dependent, but this speed is constant. So when a particle move with constant speed, its distance will always be equal to speed into time. So the distance d must be equal to omega a, and what is the time? Tau. So omega a into tau. This is my answer to the first part. Okay. So now in second part, what is the asked question? The angle between the points velocity and acceleration vector. So we have to find the angle between velocity vector and acceleration vector. How to do that? One thing is use geometry and find the angle. Second way is, as I know the velocity vector and acceleration vector in I cap j cap form, I use the dot product method. So what is the acceleration? Acceleration is minus omega square a sine omega t j cap and plus omega square a into cos omega t j cap. So let me try the dot product method. So dot product of these two vectors means velocity vector dot acceleration vector. And how to take the dot product of these two vectors? For I part, it should be multiplied with I part, and the j part should be multiplied with j part. So 1 omega, 2 omega, and this is plus, this is minus. So minus omega cube a square and sine omega t cos omega t. Sine omega t cos omega t. Now, if we multiply this part to this part, 1 omega, 2 omega. So this is plus omega cube a into a square. There is a sine part, there is a cos part. So sine omega t into cos omega t. So this will come out 0. So the dot product of velocity vector and acceleration vector is 0. It means that velocity vector is perpendicular to the acceleration vector. So the angle between velocity vector and acceleration vector is 90 degree or pi by 2 radian.